Okay, so are you looking at your notes? This is the equation that we're going to use. This equation right here is the equation that we're going to use to figure out interest. Not just any interest, but compound interest. And so we'll be talking about what that means to be compound interest. And so if we have this equation, we got to know what all those letters stand for. So the A stands for the balance. What's a balance? This is the total at the end. That's how much money you have at the end of whatever time period you're looking at. The balance, when I look at the statement from my checking account, the balance is how much is down there at the bottom after I've paid all my checks out or bills and things. P is what? Why do we use the letter P for the original amount? You need to write this word down at the end. The reason we use the word P is because in banking, the amount you start with is called the principal. Not the principal like Mr. Richardson is the principal at our school. The principal in banking terms is the original amount that you start with. The R is the interest rate, but in the equation it must be in decimal form. N is the number of times per year the interest is compounded, and T is the number of years. Now somebody pointed out in my first period class that there's a mistake over here on the side on your chart, these numbers right here. How many months are there in a year? 12. Does yours say N equals 12? It's supposed to say N equals 12 because there are 12 months in a year. Now, what one of you said when I was talking about interest rate and having it in my bank account is that's how much I get per year, 1 or 2% per year. Well, not exactly, because my bank doesn't give me interest per year. It doesn't wait till the end of December and look at my account and see how much money I have and then figure out the interest based on how much is in the account at the end of the year. My bank compounds the interest monthly. Every month, they put a little bit of money in my account that I have earned for interest. My bank compounds monthly. Every month, they give me an interest amount, a certain amount based on how much is on my account. And so let's do example number 1 and figure out how that works. The amount of $500 is deposited into an account. The $500 is how much you start with. That is what the letter P stands for. P is the principal amount of money that you start with. The account pays 9%. That's the interest rate, but it has to be written down in decimal form. To change this into a decimal, you do 9.5 divided by 100 because percent means part out of 100. It is compounded monthly in this example. How many months are there in a year? And this account is for 3 years. So the little chart is to help you get all the information organized, and then you fill in the equation. A is equal to the principal amount, 1 plus, because this is increasing in amount, 0.095 divided by 12 raised to the nt power. That means you multiply the n times the t. It's easier to fit it in the calculator if you go ahead and multiply 12 times 3 is 36. In this part right here, are there any variables, or is that all numbers? All numbers, so we are going to put those all in our calculator, and I would suggest you put it all in one step, like it's written on the paper, so that there is not any order of operation mistakes. Now, this is money. How many, it doesn't tell you how many decimal places to round to, because you know how many decimal places money has, right? That would be 2. So I look at this number right here. Is that number right there more than 4? Then the 13 will round up to a 14. So this is 664.14. And so also, this is money, so it should have a dollar sign. And even though we say $664, the sign goes in front of the numbers, not at the back. And so this is the correct way to write your answer. Now, this is compounded monthly. If it was not compounded monthly, if it was only compounded once a year, how many years? 3 years? This is how much you would earn. That's if it's just compounded once a year. So does it make a great big amount of difference? This, if it was compounded once a year, it would be $656, and that's $664. Is it a whole lot of difference? Not if you only have $500. But if you had $5 million, would it start making a big difference? Yeah. And so, you know, it's kind of important depending on how much money you have. Example number 2. A while back, collecting baseball cards used to be a big thing because they were increasing in value pretty much. I don't know that that's continued to be a big thing. I don't think they're quite increasing in value as much. So, how much does my baseball cards, how much did they start out? The 150 is the principal amount. That's how much they started with. Do we have an interest rate? The interest rate has to be in decimal form, so you would divide this by 100 to get the decimal form. N is the number of times compounded per year. Does it say monthly or daily or anything like that? It says each year. That would be one time a year. And does it tell me the time? Does it tell me? It implies. If I start out at 1998 and I go to 2004, how many years is that? 6. Okay, and then I fill in the formula, this formula right here. The principal amount is 151 plus. It is a plus because it increases in value. 0.075 divided by 1 raised to the n times t power. What do I get when I multiply those two numbers together? Oh, you're a step ahead of me. Now, this is 0.075 divided by 1. If I divide it by 1, is that going to change the 0.075? So do I really need to divide by 1? Not really. And so in my calculator, 150, 1 plus 0.075 raised to the 6th power. That's how much it's going to be after 6 years. Is this number right here more than 4? So the 49 will round up to 50. Question number 3. How much would you deposit in an account that pays 6.5% interest, compounded semi-annually, to have a balance of $5,000 in 15 years? Is $5,000 how much I start with? In the way this is worded, the $5,000 is how much I end up with, and so A is the amount that you end up with, the final amount. We don't know this. This is what we're going to figure out. What's the interest rate? This has to be in decimal form. This says compounded semi-annually. That means 2 times a year, and this says 15 years. And this is the equation that I'm going to fill in. What is the A equal to? That's equal to the 5,000. Do I know what the P is equal to? That is what I am solving for. 1 plus the interest rate divided by 2 raised to the n times t power. This is equal to 30. Now, does this part right here have any variables in it? So I am going to decimalize that part right there. Now, I don't want to round off too much, because the more decimal places I have, the more accurate my answer will be. But I also probably don't want to write down all of those decimal points. So usually at this point, you use 4 decimal places. 1, 2, 3, 4. So you look at that number. Is that more than 4? So that one rounds up, 6104. I'm solving for P, so what am I going to do with that number right there? Okay, so I want to show you how to use your calculator on this kind of problem. That's what I just calculated. And so I want to divide 5,000 by that number that's in my calculator, right? So I am going to put 5,000 in my calculator. Do you see what it says right here above this negative sign? It says in yellow, A-N-S, right? What do you think A-N-S stands for? Answer. And it's in yellow. So if I push second negative sign, the calculator says ANS. That stands for answer. So it's going to divide my 5,000 by the answer from the previous problem. Isn't that my 2.1604 number? Except it's not rounded off. It's the entire number not rounded off. And so I don't have to type that into my calculator. I can use the answer function on my calculator. This is money. That number is more than 4, so that rounds up to 44 cents. 1915.44. And this is the P. That's what the P is equal to. Now, if you typed in that number, instead of using the answer function, 2.104, you will get a slightly different answer, 2 cents difference. And so we're not going to worry about small differences due to rounding. This is the more accurate answer, but if you typed it in for yourself and got 1915.42 cents, I would not count that wrong. Okay, not everything goes up in value. Some things go down in value. Another word for decrease, sometimes you will see the word depreciation. That means go down in value. One of the things that goes down in value is cars, except for one kind. You know what kind? Classic cars go up in value, but most of our cars go down in value. In my chart here, where am I going to put my 12,500? Is that the amount I start with or the amount I end with? And so P is for principal. That's the amount you start with. And so this is 20% per year, 20 divided by 100, because this has to be in decimal form. How many times per year? How many years? Now, this formula is slightly different than the formula we used previously. How is it different? This is a minus sign because it is going down in value. So, the principal amount, 1 minus the rate, divided by the number compounding, raised to the 3 times 1 power. Now, when it's divided by 1, what is 0.20 divided by 1? Well, it's still 0.20, so you don't have to put that in your calculator. And so I will put 12500, 1 minus 0.20 raised to the 3 power. After 3 years, I'm almost in half of my value. Now, there is one more example that's not on your paper that I would either like you to add on the bottom margin or on the back. Now, I have some investments, and if I'm ever going to retire, I need my investments to double in amount. It is generally thought, I don't know that I believe it, but it's generally thought that the stock market over time should average about 8% per year. So how long is it going to take me to double my money? So what is this number? It's the starting amount, so it goes in for the principal. The principal is the starting amount. What's this? That is the ending amount. My interest rate in decimal form, I need to divide this by 100 to get my decimal form. Since this says per year, do I know how many years? That's what I'm solving for this time. Which one of these equations up here at the top am I going to use? Is my number going up in value or down in value? So I would use this one. So the $2,000 started with $1,000. But I don't know how much that time is. And what's 0.08 divided by 1? How do you solve that? Well, I can simplify it a little bit. Now what? Can I multiply the 1,000 times the 1.08? I cannot, because it has an exponential rate here. So I need to isolate this base. Do some of these words sound familiar? I need to isolate my base. So that will be 2 equals 0.0. I'm solving for x. X is an exponent. How? Yes, this is why we learned all that log stuff for this kind of problem right here. To solve this, I'm going to take the log of both sides. I take the log of both sides so that I can use the power rule and bring that out in front. Does this look like some of the problems I was just doing? Put that in your calculator. How many years is it going to take me to double my money? However, my money has never made 8%. I just have lousy financial advisors. So if the percent, if this percent is less, what's going to happen to the years? It's going to increase.